Hi, my name is Muizuddin. With me, Ikram Was, and with me also, Zaid Harris. We continue the presentations, experiment 5, Hot Law. The agenda we want to present is first, objective, procedure, result, analysis, discussion, and conclusions. First, the objective is to verify the accuracy of Hawk law. The next slide is apparatus. We must have a helicus steel spring with spotting stand and set of slot with hanger with balance. The next slide is 1.6.1 centimeter diagram of Hawk law experiments. This is our uh, picture. We add more weight on the spring, so we record it the data in the data sheet. So we can continue the presentation with procedure. The first step of procedure, the weight of the hanger was calculated and recorded as W. W is mean the weight in the table. The scale was adjusted so that the pointer on the hanger was near the upper end of the scale when the hanger was unloaded. This position was recorded as multiple zero. Thus, the hanger was loaded with a 10-gram mass and the scale reading multiple 1 was recorded. Successive load is incremental equal was added to the hanger and to require 8 data point before reach to the lower end of the scale. All data W which mean weights and multiply once we recorded.
Okay, let's continue to the other part. The number 4 is the process was reversed by unloading the same load used in step 3. Again, new scale reading multiply 1 multiply will record for each load. Number 5, the extension of the spring uh, triangle X, triangle multiply was calculated. Number 6, the extension force on the spring F for each total load was determined. For the result, this is for the result, scale reading without load multiply 0, we get 0.17 meter. Okay, this is the table. Load mass weight gram first is 1.98. For the weight of loaded mass and hanger, W is a 0.1942. For the extension force, is 0.1642, and the scale reading with load multiply 1. For the trial, 1 is 0.18 and trial 2 is 0.181 and the average is 0.181. Uh, the extension of the spring M is 0.011 and there another loaded mass that you can see in this table. For the analysis is first plot a graph of the force cursing, the extension F again the extension X, calculate gradient of the graph. So what the value does the gradient represent? So this is the graph that we make, and this what the graph we get. So for the next part analysis, the second one is how much work done in stretching the spring through 0.20 meter. Find this from the graph. We must find gradient through the graph. So we take 0.5 uh, we take 0.5 minus 0.4 divide by 0.23 minus 0.18 and we get the gradient is 2. Okay, for number three, is how much energy stored in the spring when it is extended to 0.20 meter. So, V equal to F as the F is 0.5 and S is 0.2. We must multiply it and we get 0.1 joule. Okay, the number four is describe any error that may have occurred during this experiment. In our Hooke law experiment, potential instrumental errors may stem from imprecise measuring tools like a ruler of force got. Procedural error could arise due to inconsistencies in our application of force or inaccurate recording of elongation, possibly influenced by parallax errors during measurement. Uh, Environmental factor is such as temperature fluctuation affecting material properties might also contribute to deviation from our expect result. Regular calibration of our instrument and meticulous experimental teach help mitigate this specific error. So for the next part, I will give to my friend. Sorry for that. There's one I left behind. Is number five. Is what can you describe from your result about the relationship between the extension of a spring and the force causing extension. So force is directly proportional to extension of the spring. So I will pass to my friend. Thank you.
So, move on to discussion. Hooke's law experiment involves stretching a spring and measuring the amount of force need to produce a given amount of stretch. By comparing the force applied with the resulting change in length, scientists can understand how material behave under different conditions. So, in conclusion, the result of the experiment show that there is a linear relationship between the force exerted on the spring and the amount of stretch or compression in the spring. This means that if you double the force exerted on the spring, you will double the amount of stretch or compression in the spring. Okay, here is our reference if you guys want to check it out. And that's all from us today. Goodbye. See you soon. Bye.